So I did Steven here today, and essentially I wanted to talk to you about, or essentially I wanted to teach you how to program. Now it's kind of funny because I recently helped someone with their homework, their programming homework, and in that I essentially managed to get on film everything that I've been talking about in the Your Gateway to Programming article series. So the article series are more technology agnostic, meaning essentially it's not focused on a particular programming language per se, but it's rather more its priority, its purpose is to give you that higher level bird's eye view of what programming is really about, right? Like the very fundamentals, variables, arrays, loops, classes, etc., etc. And then because you now have that higher level understanding, you know the purpose of each programming concept and how it's properly applied, you can then go on to essentially spend very little time on building your software because all you have to do now is just check the documentation of the programming language, aka Google how to do whatever the fuck you're trying to do, right? So I figured by doing that, it'd be saving a lot of time for people while also giving them a really strong and in-depth foundational understanding of programming and the fundamentals of it, the things that essentially the essence of programming and what's found in pretty much all languages. Like all languages hold these concepts because that's how you build software, right? So it essentially makes you very, it just gives you an insane advantage over people who are maybe like really technically sound but have no fucking idea what the fuck they're doing. How you know it? You just ask them a question, and if they can't answer to you in like simple plain man's terms, like as they say, if they can't explain it to a fucking baby, then they have no fucking clue what they're talking about. So by essentially understanding everything in a simple to digest and simple to understand everything, you're able to really pay attention and know exactly why you're doing why you're doing something, if maybe when you're doing too much, and etc. etc. So as I was going through his homework, I was essentially before I went through the homework, I was like, hey, how about I just train you in a way where you can only get a really solid understanding of programming to where now you can probably more easily pass the class, but then you also get a segue or a foundational understanding or a foundation upon which you can make a career out of programming and tech if that's something you want to pursue, right? So this is what this video recording came about, and then I must say that it was like 8 fucking hours, right? Because we went into it, and then I wasn't it didn't take too long, but then afterwards I helped him with his homework, and then like around like 6 or I believe around 7 hours and 30 minutes, my fucking Xcode just started acting weird. Like you'd click build and it'd build and finish simultaneously without ever running the program. So then I'm just like, okay, I guess I'll restart the computer. Stupidly forgetting that fucking photo booth was running, which was recording me, like my face, and then QuickTime was running too. So because of that, it like force quitted both programs, and I ended up losing all the fucking content from photo booth. So I apologize, you will not be able to see my pretty face. But do know that I wish you could have seen it. So, yeah, so you won't be able to see my face, but you should be able to hear everything I say pretty well, and then just look at the screen and be breaking it down. So, as I mentioned, Oh, actually, I didn't mention it, but his homework was using C++. So that's the language we're actually going to be focused on. And I guess it's kind of cool because you'll be able to see a direct application of all the stuff I talk about on the article and kind of just see how it works on a particular technology. Anyways, hope you guys enjoy this and let's fucking crack into it. Haha. And start with something really simple. So since we're dealing with C++, it kind of makes everything a little simplified because I mean you'll see in the article, and actually let me go ahead and post a link to it. But that's also another thing I highly advise you check out. So I literally created it to be um, absolutely technology agnostic, meaning that it doesn't matter what language that you're programming in because the concept still applies. Like every language, pretty much most of them use variables and loops and whatnot. So like you should be able to understand how it works and then just okay, if you're trying to do specific, for example, in Java or VB, you just Google how to declare a variable in that language, but you already know what you're doing. And I think that's like a huge advantage to people who are just always they like that. And that's another thing that I'm noticing in this just the assignment instructions. It's like he's bogging you down and like etc.
Yes.
So that's really what I want people to do because at the end of the day, you're building a program for a purpose. And the more and more you think about that purpose in mind as you're programming, the better you will be. And the better your code will be. It will be so much more efficient because you just won't get caught up in like the minutia of it because you'll have a higher level purpose every time you're doing something. But so just for basics, um, every time you start a C++ code, there are things that have to be there, right? So you need to have what's called main or think about it as like a driver program, and it how the computer or how the compiler knows that it's the main program is by this notation right here. It's int main, two parentheses, and this and that. And what it essentially is, it's like think of a train, right? And like the the cockpit of the train where the pilot sits. Without that thing, none of the you can call it like the rooms or um, what's another way of calling that the the little carts. I don't know, like the chambers after the cockpit. The things that are linked to the train. None of them
Yeah.
would move without that cockpit. So you can think of it as like the driving engine of your program, right? So a lot of times it is in the driver program that people call their functions, right? So check or some people say get user input whenever they're trying to get data, right? They're calling a function or something like display um, calculations or display calculation, right? Or if you're doing maybe a payroll program, it'll be like display information, right? And so now what happens is um, these functions get called, right? And honestly, when you're calling a function, you usually define it, right? You define it outside of the main program. So that's a little. Um, I don't want to get too ahead of myself, but that's essentially the main purpose of defining a main function and then like making sure that it's properly signaled by. It always has to have int main and then these two parentheses and this and that. So that's always that's one of like I guess the must have for your C++ code. The next thing,
It,
go ahead.
those functions, those come from like a library of functions that you have to include, right?
Exactly. So I'm actually glad you said that because it kind of pertained to what I was saying. Like, whenever, so there's two ways of, you can think about it of, there's two, so I like to think about, well, actually, there is two ways of using something that's not defined outside of the main function. Because, and I guess I'm glad you said that, because inside of the main function, you can also create, I guess you can call it an algorithm or a function. You can do stuff here. Like, you can perform calculations, you can define variables, you can do all that within the main function, right? Now, another
Yeah.
way of doing it, as I just mentioned, is by actually creating a function separate from the main function or the driver function of the program, right? Now, the reason why I kind of backed up, because we're delving into functions and classes, and that's pretty much what you were talking about when you mentioned the include. Because when you're including something, you're essentially, every time you see this, it's
Mm-hmm.
actually including what's called a class. And classes, how I like to define them is like, think of a robot, right? So
Yeah.
like Transformers, every single one of those robots, they transform to be Autobots. But like, if you think about it, every single Autobot is different because they're each a different vehicle or different thing, right? One of them, for example, Optimus Prime, is a firefighter's truck. Another one, Bumblebee, is like a, what is it? A Ford GT Mustang, I think, something like that. And then another one is like a helicopter, right? So
Yeah.
in that way of seeing them, you can think of them as each having their own particular function. Meaning, so for Optimus Prime, when he's a firefighter truck, he only has access to like a firefighter hose, sirens, etc. But he can't fly, right? Bumblebee is like a really fucking fast car, so like top speed can go way faster than Optimus Prime theoretically, right? And
Mm-hmm.
then I forgot his name, the one that's the helicopter, can fucking fly and hover, right? So each of them has their own particular function, and you can liken this to classes. And classes again is the stuff that's called when you see include, meaning each class comes with its particular function. So an example, I'll take one of my assignments. Um, I had to write a class for, actually, let's see something simpler to explain. Because I don't want to, you know what, fuck it. I can actually just make one. So, um, each class comes with its own particular function and its own particular variables to use those functions. So I kind of have to backtrack again. That's why I was like, oh fuck, I feel like we're going to. So the basics, right? So you know how to declare a variable, right?
Yeah, like integer, double, float, bool, or
Exactly.
yeah.
Int number equals 0, right?
Uh-huh.
Double number equals 0.0. The difference between int and doubles is essentially, doubles are for fractions, and
Yeah.
then ints are for like whole numbers, right? And
Yeah.
then obviously another thing, when you're declaring a variable, make sure that they have unique names. I talked about in the article, think of variable names as a way that your program carves out a piece of space in the field that is the program, and then uses that name to be able to reference it so that it can interface and interact with that data. Right? So every variable holds a piece of data. Like they talk about, it's like it points to a particular part in the memory. And so now that you point to this, you can say, okay, I want to store this value in this memory. And so that's why the need for unique names is so important, because you don't want it to be pointing the same thing but are different values and stuff. It causes hiccups, as you saw. So yeah, there's int, double, string.
And strings hold words, right? So swag, surfing. And then I'll obviously always make sure that at the end of every phrase or line of code, you finish it with a semicolon, right?
For a statement.
Yeah,
Yeah,
exactly. Yeah. So that's variables. Booleans is like true or false. So it's
that's
usually
0 and 1, right?
yeah, it's yeah, 0, 1, or yeah, you got it. So 1 is true and then false is 0. You got it. And
And is a string, would that be like an integer or would that be an array? Because you could have like a character string, right?
yeah, so strings are words, right? Now characters is one word. But the thing, so in the assignment, for example, the cool thing about using characters is it's based on this thing called AICII, which is essentially a fancy way of saying that you can convert each character or each letter to a particular
Integer.
number. So
Yeah.
now you can turn your letter into a number, and then you can like play and do stuff with it. So let's go. Letter is equal to a, and then obviously when you declare it, there it's always one. This one thing as opposed to the string where it's like two. I don't know
Uh-huh.
if that makes sense.
Yeah.
So there's that, and then I forgot. I think the to convert a character into an integer, you would
Is it the TOEI, the array to integer?
yeah.
Or
So if I remember correctly, everything always starts from A or 0. I mean from A, and I think A has it's like 60 something. Let's see.
is that its value in the ASCII table?
Yeah,
Like 60? Yeah.
it's like 62 or 63. I forgot. Hold on.
And it's different for lower and uppercase, right?
Yeah, exactly. Um, yeah, there's a particular way of converting the character value into its integer value. I actually did it recently, so I'm kind of like, what the fuck?
In the last assignment I did in this class, we used a character string, and then we took each character in a string, and then used the like a TOEI function, like array to integer, to convert it.
Okay, you're talking about.
Yeah, that
Okay,
guy.
okay, that makes sense. Yeah. Also, remember to use the standard library table, the STL. Always make sure to include using namespace std.
STD. Yeah.
Yeah, because I
That,
I would forget to, and then like your compiler or your integrated desktop environment would be like, you'd be like, what the fuck is this? What does this mean? And then it'd ask you to add like std scout blah blah blah
yeah.
as opposed to yeah, it's because you're just always add that. Um, so yeah, I mean, I feel like you actually have a much better understanding. So that's that, obviously, and then we can maybe move on to functions because obviously we've been kind of like so we can use this example. So they call this thing function prototypes, which you can think about it as like the blueprint of the function. So what constitutes that function? And you always have to create one so that your program knows exactly what to expect from your function. So you always have to have a function prototype and then like implement the function. So something like let's say for example we did have a function called ATOI, right?
Mm-hmm.
And then you'd have to put inside, okay, are you passing any parameters? So parameters are like the shit in between the parentheses. And then like if you are, you have to tell them what data type you're using. So if for example we're using this, we say okay, we're expecting a character, and then that's it. You never have to give a name when you're doing your function prototype, but it's always kind of like wise to just do it so you never get confused. So uh, that's but then like later on when you're actually implementing your function, you have to put a name because that name, the name that you're using, like when you're using it, this is for programming purposes. You can think of this as like documentation purposes, meaning within this function now you can use number to essentially do programming stuff with it. So okay, this piece of data, I want to use the ATOI. I actually don't. Forgot. Let's go into email. Actually, Google character to integer conversion. Let me backtrack again a little bit. So obviously, just like there are different data types, there's also different. You can say, what are you expecting from this function, right? So if you're not expecting the function to do anything, like if it's more for like a functional purpose, like maybe display integers or display a number. Like say for example, we're calling display the number function, and then we pass the number, the one we created, right? If we're doing that, then we have to make sure that the function return type is set to void, because that means it's essentially empty. It's a weird word to use, but it means that it's empty, meaning it's not returning anything. That's a great way of thinking about it.
Okay.
Like, void just means it's not returning anything, but then usually anything else means that it is returning something. So you can have a function that returns an integer. So maybe a function like calculate that's receiving two numbers, right? You do the function prototype, you say int calculate, and then it's passed two integers, right? So int, right? Int. So say that calculates two numbers and then returns the result of that calculation. You can do something like int result is equal to number 1 plus number 2. And then you can say a return result. And then it'll return an int, right? Same thing for maybe it's a function that adds two strings together, right? Let's do word to surfing, right? So you can say string concatenate, which is just a fancy word for adding strings together. You pass two strings, word 1, word 2, and then you just do string result is equal to string 1 plus, and then string 2. Because when you add strings, it literally just smashes them together. So you always want to add the space in between them. Also, another weird thing about C++, it doesn't natively have a data type for strings, which is kind of weird to think about. So you always have to include the string class to it. So yeah, and then you just do return result, right? So notice how like every time, oh shit, whatever you're expecting to return, or whatever you're expecting it to return, make sure your setting it has the return data type for that function. So if you're expecting a string back, make sure a string, the function starts with string, the name of the function, the parameters. If you're expecting an integer, function starts with int, the name of the function, and then the parameters. Wow, that's really quick. Dude, typing this out and talking about it is so much fucking longer. Oh my god. Yeah. Okay, so that's functions. And then obviously you can now call on them. Alright, so calculate. Let's say, let's use number 0 and 10. I don't know. Let's calculate number and then number. So number 1, number 2. Sorry about that. Let me know if you have any questions about anything I'm doing. So calculate this number, and okay, we're not displaying anything yet. So what we can do is create a function that displays both the numbers and then the words that we made, right? So for a display, let's say content, I don't know. Actually, let's have it display. Yeah, actually, let's do that. So we're gonna get the result of this, and then we're gonna get the result of this, and then we're gonna save it in a variable, and then pass those two variables and those two operations into the content displaying function, and then display everything. I hope I didn't talk too fast. That made sense.
Colin.
Okay, so we do int calculate, and then calculated, and then string concatenated. Concatenate word 1, word 2. Sweet. Alright. And then, so now let's create that. So we now have to make a prototype for the void. 1, 2, 3. Okay. Called display content, and then it's passed our two data types. So one's an int, and then one's a string, right? And so the int is calculated number, and the string is added words. And I just kind of spelled them out a bit more just so I don't get confused, and I'm able to kind of keep track of what I'm doing. That's like probably the hardest thing. Like imagine you're doing this for hours and hours, and then you're like, fuck, where am I? Like you just go to like bed for a second or something, or you get a drink, you're like, oh shit, where am I? And that's another thing why they always strive to write comments about everything. Yeah, I fucking love this guy. If you need anything, if you're like entrepreneur minded, need to learn about business, marketing, fucking follow Gary Vaynerchuk. He's the bee's knees. But if you need comments, make comments about your code. Just kind of like, okay, this function displays content. This function adds two numbers together, and then this function adds two words together. And like, you don't have to do it for every single fucking line, but like, usually when like you're getting deeper into something, say you're writing a really long function or a really long program, it's kind of good to like, right? Maybe you're at like a point where like, oh fuck, I have to think about how I'm gonna solve this purpose, how I'm gonna solve this problem, because, and you know, it kind of goes into the pseudocode, right?
Yeah.
He was saying like, okay, your program has to do this. It has to read in read in a file, and then keep count of each letter that's found
Yeah.
into an array. Like it's really a really good idea. Is that's actually something I do whenever I'm doing my assignments. Like write in the comment. Okay, say or state the purpose, so state what you're gonna do, and then like literally write out in plain words how you're going to go about doing it. And I swear to God, when you do it, you put it at the top, it makes everything so much smoother because you might get to a point where like you're fucking writing all this shit and you're like, wait, what the fuck am I even trying to do this for? And then you go back to the top and you're like, oh yeah, and then it makes your programming that much smoother. So like, don't be like, because I know there are some people out there who are like, comment every single line. I want to see it. Nah, dude, like, just only put it in when you know for sure. Like when your soul is like, I should probably make sure that I'm clear headed, and when I'm doing this, that's when you most likely should need a comment, or even things like that. When it's like, it could like really help simplify reading the code by like 2 or 3 minutes. That's when you should comment out your code. But don't be one of those persons like, this line does this. It's like there is such a thing as too much documentation.
Yeah.
So, this it displays the content, and then these two results are passed, right? So now let's call this function to display our content. Calculated, concatenated, right? And then here we will display the count. So you know count by now probably, and that's pretty much like the message for C++. So it always starts by count, and then the 2, and then that's you put your message. So you can say something like the result of the 2 added, or adding to the 2 numbers together resulted in, and then
you put your
what is it? Calculated number. And then something that I always do is end line, and it just ends a line, and it's a lot cleaner in my opinion than the there's just like this character. It's like new line. You can do either or.
Yeah.
But I tend to like use this because when I'm looking at my code, it just looks cleaner. Like anytime I can make use of symmetry in my code, even though it sounds gay because you're like, now we're talking about like code design, like what makes code look good. Right? It just makes it easier for me because later on I can be like, okay, this line does this line does that, and it just simplifies stuff for me. So that's
we only need to use the cout if we're gonna like show a variable to the user, right?
Yeah, exactly.
Otherwise, we would just use the printf function if it was all text.
So I think printf is more for when you need to program the output, and that's actually something we're gonna have to do. And I'm kind of glad, and at the same time sad that like that came up, because that was one of like my most hated. Because like you actually so let's actually look at it. you have to first look at printf, like the printf function, see how it's used, and then look at the settings, right? So let's see, it's open. Let's actually go ahead and open the assignment. Dude. Free sexy video message, yeah. Dude, my mail has frozen. Poor computer. Alright. So, yeah.
Yahoo Mail.
Dude, it's so funny too. I'm like, this is like the classic, the older version of the mail. And every so often it keeps trying to like kick me to the new system. But I fucking hate it because this one is actually more functional. Like, you're able to look at way more emails, and then, in my personal opinion, it seems to load faster. Like, I think it's just because like I have a lot of shit open, but like it always seems to load faster, and like the most important thing, the searching mail feature is a lot cooler and better on this one than on the new one. Like the new one, you can't do shit, and it's like you can clearly tell, like just the design of it too. They were literally trying to like jump on this fucking bandwagoning trend of like trying to make your design look like a mobile app. I'm like, you don't have to do that on everything. So, but yeah, dude. Like, no matter what people say, it sucks in the fact that like their filtering system is too good. Like some of my emails never get to me. But at the same time, I feel like it's a lot better than having all this spam in your inbox get in there, like in Hotmail, for example. Like that's their dude. Like my Hotmail is just full of fucking spam, and it's I've like tried to like go through it. I just gave up. But yeah, I just probably have a lot open. Anyways, we can look at it though. So printf. Should probably close Premiere Pro. Well, I guess in the meantime, yeah. While that's loading, we'll just finish this. So, adding the two words together resulted in, and then, yeah. You always envision the space. That's what I always do. Because it doesn't add that for you. Added words. And then, oh fuck. And line. Okay. So you save that, and then let's run it. Damn, computer. I need RAM. Dude, I'm on a MacBook Air too.
Really?
Yeah. I don't know. I think I need a
are you using the Xcode?
Yeah.
I just now noticed that.
Dude, I like it because it's so lightweight, man. Like, it runs really quickly. It doesn't lag as much as like, or crash as much as all the other IDEs. Simply because it's so lightweight. You know, like the tools. Like, it only gives you what you need, and then the cool thing is it's integrated with the OS. So like I feel like there are features like when it comes to like memory management and all that that really it just helps you. Like if I was to ever actually develop like software, I'd be able to use the features of the OS to see how it plays on the digital resources. So I'll show you. Running tutorial. Yeah, it's like really slow right now, just because like I'm like recording all this stuff, I think, and then we're running screen share too. So if I can get rid of a few things, I'll probably help. Yeah. Okay. So. So there it is.
Oh, cool.
Adding two numbers together resulted in bang bang. So that pretty much sums up functions. But yeah, just it's all about the function prototype, making sure that it matches what you're expecting from the program, and then also like replicating it when you're implementing it, and then making sure that you add names for the data types so that you can actually use it to do programming stuff with it. Um, so now, I guess we can talk about how to build a class because that's pretty much the next step from there. Um, so again, as I mentioned, it's like think about it as like building your own robot, right? And every robot or every class has a particular variable and then the functions that use those variables. So you always create at least what I like to do is I create my class using an H header file. And like the reason I say what I like to do is because let's say robot. Let's create a class called robot. But there's like so once you get into a bit more programming, they'll start talking about how um, there's like different thoughts about how you should do it. Some people say you should create a header file that kind of talks about the program, like the class itself, and then you close that, and then you write the code that implements it. So you in the header part of the process, you talk about what you want the class to do, and then in the implementation part of it, you essentially actually build out the code. So in the header file too, you kind of build like a light exoskeleton. I'll show you. But the reason why I like to just do everything in one is because up until now, um, I feel like breaking the two is more work than actual necessary. And like the argument is saying, yeah, it makes stuff cleaner and blah blah blah. And like if you're maybe in like a group or in a team and you guys are all working on the same thing, it makes it so like because if you keep everything in one, there's a possibility that if someone does something, it will screw everybody else's work, right? But like the way I always felt, it's like I think that's when you can really see how aligned and how well a team works together. Because if they can't agree upon another, like agree with each other that hey, we should make sure that the blueprint of the class stays like this, and then just build out the functions that we need, or we should only just use these variables and make sure that everything else goes from there. Then you can't say that that team really works together. Like if you're just making it to where everyone can do their own thing, but then like later on the program unnecessarily becomes slower or bigger and takes up more memory, then it's like a waste of time, and that's not swag teamwork. At least in my opinion, like it's all about just being on that one frequency, and like being collaborative is that. And when you're on that level, it's like it's like there's this harmony that's just naturally there, you know. And it's almost like you guys finish your each other's phrases or trains of thought or even fucking lines of code. You know, it's not just like everyone's like veering into, you know what I mean? Like it's like
Yeah.
little symptoms or things like that. That's what I think about because I'm always thinking long term. I'm always thinking growth oriented, and then more than anything else, I'm always thinking like how can it become self sustainable, or how can you make it to where there is very little maintenance needed, you know? And like the only way in my head is just like by keeping things really simple, by keeping things really purposeful, and then by keeping things really efficient so that now there's not it doesn't pull on digital resources as much, or it doesn't waste digital resources as much as like a huge unnecessarily big program does. So but yeah, that's kind of what I was mentioning. This is like the header. It defines all the functions and then the variables for it, and then it does the implementation part outside of the class, which in my head's kind of stupid. So, um, sorry, teacher, but I would go my own way on this one. But so every header file, every class file always begins with this thing. It's like if ndef robot.h, which is the name of the class file, and then define robot.h. So what it essentially means, if there is no class file with this name yet, then create it, pretty much. So, and then at the end of the class file, you always put end if, right? So, let's begin. So you write class robot, and then there it goes. And then oh yeah, so a small thing, I guess, kind of caveat, kind of talk about scope. So there's and apparently I just realized there's more than two now. There's most of it. The the main scopes that you're going to be dealing with is public and private. Public means it's accessible by everyone, right? So
Mm-hmm.
beyond the class file. So if you use it in this main function, then that means it's public. Private means that it can only be used within the scope that is defined, so within the class file only. So if you define a variable with a private scope, it can only be used by the class file. If you define it with a public scope, it can use by everyone. So generally, you always want to essentially define the functions as public, and then but leave the variables as private. So that way the class can use it. I mean, you define it public so that people can use it. So within your program, like your main driver program, the main.cpp, within that you can use the functions of the class. You can essentially use the robot and the functions that it provides. You can use Optimus's Prime's fire hose, or the helicopter's flying function, or fucking Bumblebee's speed, right?
Yeah.
And then, but you leave the variables private so that the data doesn't get tampered with. So um, if you're using a function, say for example, you use Bumblebee's speed to go to a particular speed per hour, and you want to maybe keep it at that speed, you can save it because you declare that data, that variable has private, so it won't be messed with unless there is a function that particularly changes that variable. My point is, you're keeping it private so that you're essentially okay. This is actually a perfect way of putting it. Say you can say int speed, right? And then say you have yeah, you're making it like this so that now only this class can change that speed. And it's not yet apparent why this is important, so I'm gonna try to accelerate. So the void function, the accelerate function is void because we're not expecting anything. We're just trying to change the speed of the car, right? And we're gonna give it a speed to accelerate it to. Um, let's see, what else would be stop maybe, right? And then we won't pass anything because stop just makes speed go to 0. And then accelerate, stop. That'd be it, right? Now, the reason why, oh yeah, actually, let me talk about this first before I go into it. But by making it private, you're essentially making it to where if people want to interface with the robot, if people want to use or change the speed, they have to go through the robot's interface. So think of a class as like, say you have, um, they talk about objects in programming, right? So an object is comprised of um, its own data and then the functions that interface and interact with that data, right? Now, to use an object, you essentially include it in your main program and now has a class, right? You're essentially calling upon that object. And to essentially benefit of the functions and the abilities of that object, you use the functions that it makes accessible to the public, right? Now the thing is, if for example someone was a bad guy and they wanted to fuck up your shit, and you essentially made this data public, they could then directly access the variable speed and put like some weird input in there. They could instead of making it an int, they could make it a word, right? Like go really fast. And then that would crash your program because it's not meant to operate that way. So it's essentially by doing that, you're protecting not just the program, but the user from the user itself, or from even attackers. You're essentially making sure that it's like think of it as like access controls, making sure that the only people that access and manipulate this data directly are the ones that are qualified to do so. So the class itself, not like the general public. So that's why you always put data variables as private instead of public. There is more. Apparently, there's like a protected and like protect inherent. It gets crazy, but these are the main ones that you are gonna tend to go with. So always keep that in mind. Make sure that your class variables are private. And then one thing I also wanted to say, what I was gonna is like you want to have what's called a constructor. So a constructor is essential. So if I were to create a robot, right, and I wanted to give it values initially, so if I wanted to make sure that they're like, say for example, I was creating an Autobot, right? The main values, at least for default, like obviously, is to make sure that it can transform, right? It can go from the vehicle to the robot, the fighting robot itself, or that it could essentially communicate with all the other Autobots. So it had essentially um, it had access to that communication frequency, things like that, right? It's like giving default values to your robot. What you want to do is create a constructor, and to do that, you essentially just you call the name of you write the name of the class, and then you put two parentheses, and then you put the values that you want. Right now, usually what people will tell you to do is you want to create a default constructor, meaning whenever people use this object, and I'm gonna start trying to like insert the programming because now you have a better understanding of it. But whenever you create the object that is the robot, you want it to have default values. So maybe you want the speed to already be initialized to 0, right? Or yeah, that's pretty much the main one. Because right now I'm just kind of focusing on the car. It's like the easiest. But you always want, for example, the speed to be 0. You don't want like to create something that's like out of the gate. It's already going at like 70 miles an hour without having any tracks, right? So that's one. Another thing too is like they say to sometimes also create what's called a parametrized constructor, meaning now, say for example, someone like the public wants to give that particular robot a particular value for one reason or the other. Say for example, we have a variable called string name, right? Maybe they want to give it a name, right? If we're talking about a real car, for example, maybe you'd want to give it the name and the make, right? And then like maybe even give it like particular properties like top speed, things like that, right? Like for example, a truck can only go so fast, but like a Mustang can go even further. So that's how you'd be able to do that by allowing or creating a parametrized constructor, which means that you're essentially allowing the public or the user to create an object with the values. The values are not default, but rather are the ones that they want to give it. Right? So maybe they want to give it a name. So right now I feel like that's kind of like the only parameterized or the only value that for this scenario just makes sense to essentially allow people to change. So you could say something like string nickname, right? And then so let's say usually it's Bumblebee. Dude, I love Star Wars. Like every single one of those movies in my head was epic. I can't wait for the new one. It's gonna be epic. So say you want to you want to give it its own name, right? So then you would say nickname, or you would say name is equal to nickname, right?
Mm-hmm.
Now, so that's pretty much how you would do that. So now, whenever someone creates a robot, oh, this is how you create. I guess I can actually use the word. So this is how you create an object. So object is essentially using the class in the program. That's the best way of thinking about it. But this is how you would create an object. You would just say the name of the class, so robot, and then you would give the name that you want to reference it to. So remember how like names always have to be unique, so the program can. So you would give it on a name robot one, or let's say Autobot is equal to new robot, like that, right? Oh, and then always remember that to be able to use that class, you have to include it. And when you create your own custom class, you put it into, you use the two things instead of the bracket. Include robot.h, and then you have to also obviously compile the class file. So we haven't finished here, but I just wanted you to see ahead of time, excuse me, how you would do it. So once you did that, you would actually be able to use the robot. So you'd be able to do stuff like autobot.accelerate or autobot.stop. Okay. So, oh yeah. So we remember these are the function prototypes. So now let's actually create the function. I feel like I'm missing something. What am I missing? I think you actually have to write. Yeah, I think you actually have to write it. So, yeah, I haven't. Okay, let's see. Int speed. Okay, so speed 2. Okay, and then you would just do speed is equal to accelerated. So I'm writing the function that accelerates to. And let's stop. Speed is equal to 0. That's pretty much it. So, what if maybe you wanted to get the speed? So these are, they call them getters and setters. It's essentially, I like to think about it as like getting the, you know how like there's the temperature things and you can like drop in water and it goes tick and then you're able to, or even better, it's like when you're drawn, maybe you're like diabetic and you gotta like prick your fingers and go tick and it tells you like how much like insulin and all that. I pretty much think of it as like getters. And so getters essentially, I think I would define it as getting the actual or current condition or current value of your data, and that's usually what people use to access variable um, the value of the variables for the classes. So remember how instead of just directly writing speed here, like instead of just directly displaying speed, so if instead I was writing display speed for this function, right, I'm not going to change it, but just for the sake of it, imagine if this was display speed and then like this, what was passed was the robot, right? Instead of just directly writing speed, again, you can't directly access the variable, so you have to use what's called a getter. And I know right now it kind of doesn't make sense as to why, but once you see the full class, you'll realize that, oh wow, like it's literally creating an architecture that like protects the integrity of the class from being directly modified, and then by doing that, you're protecting it from getting like illegal input that could literally fuck up a program. Because literally, like putting in a string value instead of an int will cause your program to shut down. So when people like you have like these multi-million-dollar programs and they break down, it's because somewhere maybe a value is like not private, it's like public, and then it can like the littlest things, I swear. So public get speed, and then it's not pass anything, and maybe int get name. Right, so you always put getters and setters for each variable. Now, I'm actually going to go a step further and even do it for the nickname. So instead of directly accessing it, I'm going to also use the setters for the constructors. So set speed and then set name, and then this is passed a particular value. Oh, actually, I already did that. That's my accelerate, but I guess we could say set speed just to make it less confusing. Set speed, get name, and then something I always like to do is put like the getters and the setters right by each other, so I know they have, it's like a complementary pair. So int our string set name, just like that. Okay. Let's oh, oops. So now that we have a function for set name, we can actually just use it here. Okay, so now we gotta create variables or functions for all these things. So get speed, void, set speed, stop. So get speed will just return speed, so return speed. And then stop would not. I already did stop. Set name would return. Oh, it would. Oh, that's past something in it. Yeah. String. Nickname. Yeah. So then you would say name is equal to nickname. And that's void because it's not returning anything. So that's also a simple way of remembering it. Anytime, most of the time when you're doing something functional and you're not really returning anything, it's voided. So setters tend to be voided, and then getters tend to return something, so it tends to have a data type added to it. And then get name, return name. Okay. So now your class has everything it needs to run like a champ. Oh, yeah, it's saying you haven't compiled your stuff yet, bro. Okay. So, and then end if. Yeah, my issue I was having, I was like, wait, because I remembered at some point writing everything within the class bracket. Let's see. Oh, your thing loaded. I can't remember. Oh, let's see if this works. Okay, so you compile your header file. For your class. And then that's able to, oh, it's saying a lot of issues. Okay, expected 0, at 1. String, oh, remember, include string. That like causes so many issues. I remember in the past how I'm like, why is this doing this to me? And it's like, you didn't include string, bro. Or you didn't include namespace. That was a huge one. I didn't realize how many things counted on that one line. Okay, too many arguments, set name. Oh, so that's supposed to pass a string. And that's always also an easy thing to remember. When you're setting something, you're going to pass it. So, silly me there. Let's see. Use of undeclared identifier. Speed. Okay. So I guess I was right. Has to go inside. Yeah, I feel like I'm like relearning this stuff too. So when you're writing classes, you don't even need a prototype. You just directly, at least if you're going my everything in one place way. Because, here, I'll just finish writing this and I'll show the other way too. So I don't want people to be like, he said his way was the only. Okay. Space. Okay. Set name. And then. So, as I've just painfully learned, and you saw, when you're writing your class, you can just go ahead and directly write it. Like, you don't have to create a prototype and then define it like in the main. You can just directly do it. Or you're supposed to directly just do it. So, return. Oh. It's little things. You put string int when you were supposed to be int. Like what? Okay. So, header class has been created. So now, once you've created your class, you can And then let's read how fast it's going. So, okay, I'm going to go ahead and remove these functions. You pretty much got the gist, right? Do you have any questions on these?
No.
Okay. So I'm going to remove them, and then make space for new ones. Okay. Now let's see what issue we know about. I always thought you had to put new. Oh, I'm wrong again. I think you're supposed to put new whenever you have parameters for your constructor. Use of undeclared identifier. Oh, Oboto. Oboto. So, just a test. Let's make sure that it actually did change the speed. So, the current speed of this and then let's put the name of autobot.getName is, and then autobot.getSpeed, and then endline, and then and then let's put stop, and then let's try that again, and then let's change its name. It's autobot.setName. Let's say we can get into sin stuff because that's gonna be what you have to deal with receiving user input. So, would you like to give a nickname? Name. Enter yes. Yes or yes or no. Right. So then you put endline, and then you do sin. So let's create a new variable. I like to use strings whenever I get user enable. I like to use strings just in general, but for this situation, you should probably because strings are more for like words, and then characters are for like single letters. So char user input, and you say user input, right? That's when it's gonna get it, and then then you say, okay, so so then it's like if user input is equal to yes, right? Then you ask them, okay, what is your desired nickname for this robot? And then actually, enter your desired nickname for this robot. And then that's when you do you have them endline send user input again, and then use that to essentially say the new nickname or this robot is now called then you say you set the name, sorry, set name user input. Oh fuck. So I have to create two variables. One that holds a user input, another one that holds a nickname. In my house kind of, what if we could just hack it real quick and just make it all in one? But I'm using a letter or character and then another one. And I think that's probably another reason why I use strings. They're much easier to repurpose for something than my characters are. So nickname, set the nickname, and then you just to make sure this robot is now called autobot.getName, and then inline, right? And then if user input is equal to no, then let's just end the program then there. And that we can just do exit. Okay. Dun 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 dun. Programming.
Right? Will it compile?
I know, right? It's like drum roll.
Nice.
Let's see. Where are you now? Okay, sweet. Alright, current speed of Bumblebee is 40. Right. Then we put stop. I guess I like to always write everything. Every time I'm using a function, I always like to display a message. Just it's like good user experience, you know? Okay. Stopping the car and mine. Okay. Oh, actually, let's put stopping autobot.getName. Robots are people too. They have feelings. Sentient beings, bruh. Okay. Autobot. Sweet. Okay. So current speed of Bumblebee is 40. Stopping Bumblebee. And then current speed of Bumblebee is 0. Just to make sure. And then let's say yes. We'd like to give it a nickname. Yes. Enter desired. What would you like to nickname it?
I don't even know. Let's call him what? Let's call him. I don't even. I'd just call him anything.
Anything. This robot is not called anything. Okay, so that worked. So I hope that helped clarify classes. Just always you start with .h, and then as you saw me painstakingly fail at, once you declare once you declare you just write your functions. So it's actually funny because I always see it. I don't know why I didn't think of it, but they always start with private and then public.
Yeah.
So you declare your variables. Always keep them private, as I mentioned, for security and all that. And then you write the public and the public functions. And then once you do that, you also write your constructors, so the things that give the default values. And then you also write a parametrized constructor in case the user wants to give his own values, right? And then in the code to use it to create an object of the class, you essentially use the name and then you give it a name, right? I think you can also do, so that's probably what I was trying to do earlier. You can say new robot and let's call it Sam. Let's call it Sam. It should work. What? Yeah, it's all about dynamic allocation. Okay. So you just directly put in the parameter that you want it, and then that will probably work. I'll just do it real quick. Count. This robot is now called. Let's check the current speed of. Let's find out how fast Sam is going. She should be going at 0 because that's the default variable. And Sam is, and then let's find out how speed. Get speed and done. Right. Oh. Okay, I got it. Yeah, I was like, no, I saw a typo. I knew it. Sniper eyes. Just kidding. Right. Sniping the poon. Okay, so that should work. And then this time I'm going to put N just to see if it really closes out the code. So Sam's current speed is 0. That's correct. Current speed of Bumblebee 40. Stopping Bumblebee. Autobot.stop. And then current speed is 0. And then let's see. And program ended. So it worked. So that's how classes work. Constructors, parametrized constructors, and then their private variables or variables that are private for the sake of security and just overall architecture, and then public functions so you can use them here, right? Did you have any questions about that?
Oh, no.
Yes, yes, I'm doing good. So I think that's pretty much what I wanted to mainly talk about, because I feel like from there it's all about, because if you understand functions, and then you also understand how to read the prototype, the function prototype, then you know what to put in there. Now, it sucks because sometimes people are actually even bad at writing prototypes. Like, what the fuck does this mean, bro? You know what I mean? Like, it could be a lot simpler. But for the most part, it'll give you a stronger leg up when you're doing your programming homework or any assignment or even software. Like I said, if you choose to make a career out of it, you'll just get a better understanding of what you're doing just from understanding everything we went through. So, one thing that I really wanted to delve into now is I don't know if I want to talk about the file write. Well, I guess let's talk about it. So, how C++ works is if you want to open or read a file, you need to essentially use the function called fstream because that's what does input and then output, right? So offstream does both, meaning it reads files, it opens files, and you can write to files as well, as you can read here. Ifstream is when you're only reading from a file, right? And then offstream is when you're writing from a file. So it's just like earlier when I was using sin and sout, or cin and cout. That's what you would be replacing it with when you're writing or reading from the file. So that's pretty much what I wanted to cover on that. Like, now, as I read, our assignment is going to be dealing with arrays, right? So I guess that's something we should also touch on. So to declare, how I like to define it is think of arrays as like visualize in your mind's eye like a square, right? A perfect square. Now, visualize how, if for example you have an array that has a capacity of 10, meaning within this giant perfect square, there are literally 10, you can call them partitions, or 10 perfect little squares that perfectly divide the array with, like, they all have the same volume, so the same length and the same length. So an array of 10 elements means that there is literally 10 squares within this giant square, and each of those squares hold a particular value. Now, the array itself always has the same data type, meaning if you declare an array of integers, every single perfect little square within it is all only holding integers. Same thing if you're declaring strings or characters. So that's essentially how it works, right? I'm gonna go. Oh, do you have any questions before I remove this?
No.
Okay, so to declare an array. So what?
An array always starts at 0, right?
Yeah, exactly. It's so if, for example, I have 10 elements, the array indexes, meaning the way you're gonna reference each little square, you go in the sequence from 0 to 9. So 0 to 9 is 10 elements. Same thing for 26 elements. You'll go from 0 to 25. It's always 0 to capacity minus 1. Think of it like that.
Yeah.
So declaring an array is just as simple as this: in array, and then you add the bracket, and then you put in the number of elements within it. So that's 25, right? If you want to, and you probably know, but like you can't do something like directly put a number to the array because it's it's different things, right? So if you wanted to, for example, put 4, you'd have to essentially manually write 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, like 25 times.
Yeah.
So this is where essentially we're getting into loops, because with loops you're essentially I like to think about it as like so if you look at a code and you're using your mind's eye, arrays are like giant square, is like the giant perfect square, and then within it they're small, perfectly equal, volumed little square within it, and then loops would be like a giant circle, like, and literally that's what it does. It just circles around, doing the same code over and over and over and over again. And it has an escape clause within it so that it doesn't just run the code forever, but it runs it until a certain condition is met, right? So
Yeah.
there is, so an if statement, you can think about it as, well, actually it's not. It's more like a conditional. So there's a
It's
while.
like a
Go ahead.
false.
Say what?
Is it like a true false thing?
Yeah, exactly. That's why
Yeah.
it's conditional. It's more of like yes or no, right? It's like it's kind of like the fork at the road. That's another way of visualizing it. So you have if, it's like in 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 your mind's eye, the array is like the giant square with small squares. The loop is literally a circle. The if statement is like the fucking tree branches, like just the forks at the road. So if this is true, then go there. Else, if not, then it go that way, right? So
Yeah.
now there's the for loop, there is the while loop, there is the do while loop, and the only difference within them is just the way that it presents the exit clause, right? So let's start with the while loop. It essentially means while this condition is true, perform this code, right? So while this condition is true, do this, and then the moment it's no longer true, go out of it. So, say for example, um, uh, let's say that we want to read every single value in the array, right? There's a function for arrays that's in the STL library called length that gives you the capacity of the array, right? So let's say that, and we know that um, the length is 25, and we know that the index always starts at 0, right? So we can have this counter variable that essentially increments 1 every time we go to an array. So we go to index 0, read the value, then we increment the counter variable by 1 to go to index 1, and then just read that value. Then increment 2, 3, 4, etc. until 26, essentially. Because at 25, it's going to increment, and then we're no longer going to be having this condition to be true, right? So let's say that our count variable, or it's called I, and we start at 0, and then we say while I is less than 25, or less than the array length, which is 25, then perform code, which is count, read, or display the array value. So you can say count array dot I, right? And then we always add like an end of the line so it looks nice. And then once that's done, let's increment I by 1 to go to the next array element, right? Is it length or size? I think it's size. That's size. There is a function that returns the length or the size of the array. Just give me a second. The struggle. Dude. Yeah, Google is your best friend. I swear. Get size of. Size of. Let's see. And then do I have to include a function? Yeah, there's certain things that are weird about C++. Like sometimes, for example, you actually have to like simple functions like these, depending on the data type you have, it has you do like some weird operation.
Mm-hmm.
Like I remember a while back, I was actually trying to do this for an assignment, and it like the way I had to do it is like divide, because the function returned it in bytes, and I had to divide it by the size of the byte itself. So I had to divide it by itself, and then it would give me the amount of elements. Because every array or whatever holds a piece of memory, right?
Yeah.
Like a particular amount of space. So if you know how much one holds and you know the total amount that it holds, you can divide it, and it theoretically should give you how many elements it has. But I remember how I think it's actually include array. In the past, I was actually able to just do array and then use this function. Okay, let's try max size. Yeah, I have a feeling we're gonna have to do that weird thing. So, unless I'm missing something. No. That's odd. Oh, it's an array vector. So, yeah, I'm trying to figure out, because I swear, like, in the past, I was able to actually just use array.size and would work. But now, like, it's almost like it doesn't work anymore. It says member reference, blah blah blah. It's not a structure of like or a union. And so I was like looking at this example of the guy using it, but like the way he declared his array was he wrote it like this, int 25 my array. And my guess, and I mean I'm probably wrong in this. I wouldn't quote me on this one, but like this is like an array vector, or it's like using dynamically allocating an array, which just means that you're letting the computer define how much memory it's going, or you're essentially letting the computer manage the memory on its own, as opposed to setting. Like when you do this, you're basically saying this is exactly how much memory you're putting away from this. When you're doing this, you're essentially saying this is how much memory I need right now, but feel free to add as adjusted. Right? That's my guess. Like, don't quote me on that. And it's just weird how, like, I mean, it works, right? Like, I was, so you use int and then 25, and then use array int and then 5 and then my array. Expected parentheses for function stochast or type construction. You know what? It's just, I don't know. I admit when I do not know things. So because of that, I'm just going to keep it even simpler. Why don't we just stick to putting 25? So we know there's 25 elements, and we're incrementing every single time. So at the 25, it's going to increment it one more time and then kick out. So, okay, and then right now we don't have anything for any of the elements. So, say for 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, fuck, 16, 17, 18, 19, 20, 21, 23, 24, 25. Right? So this is hard, and like in a bit we can actually use a loop write this in. But for starters, so I filled in every single of those squares in ascending order. So when it runs, it should literally put it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But yeah, that's how you fill it. It's like these particular brackets, and then the variable data type, and then the comma. So that worked. So now, how about we actually use a loop that does the same thing? So we know there's 25 elements. Actually, we'll probably have to use 2 loops. So while I is less than 25, right, use, and then we're going to have to use another, let's go with int x equals 0. So while I is less than 25, while use another variable int j equals 0, and then you say while j is less than 25, array I is equal to j. Array.x. Sorry. So we're saying, so while the first one is essentially keeping track of how many elements we're going through, and then the second one is actually putting, well, you know what? You probably don't even need to write them twice. It's actually kind of cool. I'm able to like talk out loud and not feel crazy. So you could just say array x is equal to x. So this one is going to be 0, right? Actually, x plus 1. Right, so this is going to be element 0, number 1. Then it's going to increment by 1, and it's going to go index 1, number 2. Index 2, number 3. Index 3, number 4. Right, because it goes from 0 to 25, right? But the numbers is 1 to 25. Okay. The last one might probably, oh no, let's find out. Will it go 1 to 25 or 1 to 26? Dun, dun, dun. The mystery. And then the second one just reads it. Reads the array. Yeah, 1 through 25. Because it goes to 25 and then it kicks out. Right. Okay. So those are arrays. That's the while loop. The next one is we can do while loop. And again, as I mentioned, they only vary by the way they write the exit clause. Right? Yeah. So this one just directly puts it. And if you notice, the way this one is made, you always have to put a counter variable right before it and increment it within. Right. Now the do while loop, it's essentially, it's pretty much the same thing. So do, and then you would put the code. Oh wait. Did you have any questions?
No.
Okay. Okay, so do this while that is going, and then the also thing is like, it you can think of it. Oh wait, what did I do? Do while. Should I declare it? Yeah, so both the while or the do while, you need a counter variable declared before, and then we'll convert this to a do while as well. So do while so do the code or yeah. It's like you have counter variable just like before, and then do perform code while condition is true. That's pretty much it. So let's run it. So while, do while, and then next we'll do my favorite, which is the fucking for loop. It just looks really clean, and like it makes way more sense when you. I guess it's kind of a good thing that all that happened because I had to do it the hard way, and it'll just make you understand it a lot better. But it's just really elegant in the way it displays the exit clause, and the counter variable. So okay, so that worked. Yeah. Any questions?
No.
Okay. So for the for loop, the condition is it's pretty much for, and then counter variable, and then the exit clause, and then increment counter variable. So how it looks is for int x equals 0, and then you put the while the condition, like do the loop until x is no longer equal to, or x is no longer less than 25.
Yeah.
But then while that is not true, essentially increment the variable, and then you do the loop stuff. And I'll just copy this. It's pretty much the same. Sorry, I know it's kind of a lot, so I hope I'm not overloading you. I try to make you laugh as much as possible to keep you engaged. And then because it like does the incrementing within this whole thing, you don't have to do it within the code. And to me, I think it's like the coolest thing. It's like, I actually care. I make your life easy a bit. And it looks good. So for for this is the counter variable, okay, and then the loop says, okay, while x is less than 25, do this code. And then at the end of doing this code, it asks itself, Is x less than 20 still less than 25? Yes. So then that's increment, and then it does the same thing.
Mm-hmm.
It'll be x is equal to 1. And then it'll look at this. Is 1 less than 25? Yes. Okay, so let's do it. And then it'll ask itself again. Is 1 less than 25? Yes. And then, so it does that over and over and over again. Oh. Oh. I don't speak English. I speak leet speak. Okay. And there it is. So that's why I use the for loop more than the others. It's simpler, and then like I like how it's laid out, because when I'm like maybe working with arrays and stuff, it's a lot easier. Just the symmetry,
Yeah.
so then it just makes designing a code a lot easier. So that's loops. Loops, arrays, function, variables, classes. That's pretty much it.
I think that's it.
Yeah.